Good morning, guys. Am I audible?
Yes, sir. Good morning, sir.
Yeah, good morning.
Okay, my screen is also visible to all of you, right?
Yes, sir.
Okay. So, yeah. So, yesterday in our last session, we have discussed about parallel programming, right? In parallel programming, basically, we are having three methods. One is parallel.for, another one is for each, and last one is parallel.invoke, and we have discussed these three things you're going to use what, right? So basically the objective is that if you are having a for loop or if you are having a for each loop, right, and as part of the for loop and for each loop, if you are doing some independent task, right, independent task means the sense that there is no link or there is no relation between the between each iteration of the loop, right? And if the independent task is going to be a bigger task in the sense, if the task is going to take some more time, right? Then in that sense, right, in that case, you can think of using parallel programming. But again, you need to do the performance measurement. You just write the code using parallel loop and you just write the code using the standard loop, right? And then you just measure using the stopwatch, right? Which approach is taking how much time. And then accordingly, you can decide whether you need to go with parallel version of the loop or standard loop, right? And then we have discussed, right? So this is nothing but your data parallelism, right? Data parallelism in the sense you are having a huge data in the sense you are having a collection of data, and those collection of data you are processing, right? This is nothing but data parallelism, right? Another thing is that task parallelism. What is task parallelism in the sense now you can execute multiple task parallel, task in the sense multiple method, right? And we have discussed, right, using the parallel that invoke method, you can call different method in the sense those methods should be independent method, right? And we discussed that not only you can call the normal method, right? You can also execute lambda expressions. You can also use execute anonymous method. Even you can also execute method with return type and the input parameter. That is what we have discussed. Again, the same thing you need to do. This concept parallel version of the parallel programming is available. That doesn't mean you can blindly use the things, right? First of all, you need to do the performance measurement, right? Once you are, if you are feeling that I'm getting better performance than the standard loop or the standard synchronization way of calling the method, then you need to go with the synchronization version, right? And if you are thinking parallelism gives me better performance, then I need to go with parallelism, right? And we have discussed that one more thing, that there is a class called parallel options, right? And if you want to control the number of multiple threads, right, that can execute my application code, then you can manage that using the parallel option class. Inside the parallel option class, there is a property called, you can see in my screen, max degree of parallelism. And using this property, you can set or get, right, the number of threads that you want to execute your application code. Suppose I want to execute my application code or my for loop or parallel version of the for loop or version of the for each loop, or if I want to invoke some methods parallelly, right? Then you can set that by using this property. If you set this property to 2, then maximum of 2 threads is going to execute your application code. If you set this property to 5, then maximum of 5 threads is going to execute your application code. But the thing is again going to be consideration, right? The thing that you need to take into consideration is that even though if you are setting this property, right, max degree of parallelism, it's basically depend on the operating system processor where you are running the application. If that processor doesn't have that many number of threads, right, then don't think that it is going to execute using that many number of threads. For example, your processor having only a single thread to execute your application code. Even though if you are setting this property to 5, don't think that 5 threads is going to execute the application code. right? You will not get any error, but the application execution is going to be done by a single thread. That is the thing that you need to take into consideration. And we have discussed the best approach to set this property is by using environment.processor count, which is nothing but going to give you the number of processors available on the on the machine, right, where you are executing this application, right? And then you just need to use -1. Why? Because I don't want to use all the CPU resources, but I want to use the maximum CPU resources. There is a difference between all and maximum. All means all the threads are going to execute my application code. Maximum means some thread will be there, right? But maximum thread is going to execute my application code. If eight threads are available on my machine, right, then processor count environment that processor count -1 is going to give you 7, right? One thread will be available, but 7 thread is going to execute our application code. That is what we have discussed in our last session. Today, we are going to continue with parallel programming, right? Most of the things we'll cover today. One thing I will left, that is the parallel LINQ, parallel version of the LINQ. And the reason is that once we discussed, right, LINQ, then we will discuss parallel LINQ. Otherwise, if you do not know what is LINQ, then it doesn't make sense to discuss parallel LINQ, right? It is similar to if you do not know multi-threading and you are implementing the asynchronous programming. If you do not know multi-threading, you are implementing parallel programming, right? It is similar to the same thing, right? If you do not know LINQ, then you cannot understand parallel LINQ, right? So once you discuss the LINQ, then I will cover parallel LINQ, right? So today, let us start our discussion. Uh, the recording is started. Yes.
Yes, it's recording, sir. Thank you.
Yeah, it's already it's recording, right? So let us start the discussion. First of all, how to cancel parallel operations, right? So can anybody tell me how we are canceling parallel operation in asynchronous programming?
Cancellation token?
Exactly, right? So in asynchronous programming, we are using something called cancellation token, right? And to use cancellation token, we are using one class. Can anybody tell me what is that class name? Cancellation token. What is that? Cancellation token source. Yes or no? Guys,
Yes, yes.
so in this cancellation token source class, there is a property called a token. That property is going to return me the cancellation token. And using this cancellation constructor, right, you can set when the token is going to be expired, right? Even though you can have one method called cancel after, right? So these two options are there. Using this cancellation after, once you create the cancellation token, right? While creating the instance, you can pass when the token is going to be expired. If you are not passing that while creating the token, right, then you can also call this cancel after method on this cancellation token instance, and you can specify the time, right, when the token is going to be expired. Once you create this, then you need to pass the token. How you can pass this? Now by using this instance, and once you call this property, that property is going to return you the token. That token you need to pass to the async method, right? And the async method is going to cancel, will check whether the each cancellation requested property, and accordingly he will throw one exception, and that exception is nothing but a task cancelled exception, right? And otherwise, if you are calling one API, right, if you are using HTTP client class, right, that HTTP client class, any method you take into consideration, that method also taking one cancellation token. You just need to pass the cancellation token to that method. Rest of the thing is going to be taken care by that method. The same concept is also available here, right? Whatever we have discussed in asynchronous programming, right? The same thing is also available here, right? In parallel programming also, we can cancel the execution of a parallel operation by using cancellation token. So the same approach, you need to create an instance, right? You need to create an instance of a cancellation token. While creating the instance, you can set the time duration, right? When the token is going to cancel, right, using the constructor. Even if you are not using the constructor to set the time duration, then you can also set this cancellation after method, set the time duration, and then how you are going to pass the cancellation token means, right, if you, right, if I'm going with the parallel class, right, then you can see there is no method, right? Nothing which is taking what cancellation token, right? There is no properties which is taking cancellation token as a parameter. You can see there is a parallel option class and there is a action element, right? You can take this for each loop source, right? But you will never find that the any of the method taking that token as a parameter. You can see for method to inclusive, from inclusive to body, but there is no cancellation token. Then how you will pass the cancellation token, right? So to understand this, what you need to do, you need to go to the parallel option class. Inside this parallel option class, is there any property where we can set the cancellation token? Yes, there is a property called cancellation token, and with this property what we need to set now, first of all, we need to create an instance of a parallel option class. Once we create an instance, then we can set the cancellation token property, right, with this cancellation token source instance dot token properties, right? Practically we will see, right? And once we set the token, then can we pass this parallel option instance as a parameter to our method? Yes, we can pass. Now, if you go to the definition, then you can see that that option is available, right? Parallel option, right? You can see parallel option, right? So a overloaded version of the respective method is available where it is taking a parameter of parallel options class, right? So basically what we can do is, like asynchronous programming, we can also use the cancellation token to cancel the operations in parallel programming. We can use the same cancellation token here also. The parallel option class provides, right? So the parallel option class, this is the parallel option class, provides the options to cancel the parallel execution, right? If you go to the definition of this class, then you can see there is a property called cancellation token, and using this property, we can cancel the parallel execution of unparalleled operation. What this property, as we have already discussed, this property is used to get or set the cancellation token associated with the parallel option instance. It returns the token that is associated, right? If you can set or get the cancellation token. If you want to get, then you can also get. If you want to set, then you can also set, right? Let us first see one example, right? Without using without using cancellation token. So you can see, first of all, I'm creating the parallel option class. I'm setting the maximum degree of a parallelism to 2. So what it means? Can anybody tell me what it means?
Only 2 threads.
Only 2 threads.
Or yeah, maximum maximum, not, you can say 2 thread, because if your application is a single threaded application, sorry, if your server doesn't support a multi-threading, right, then in that case only one thread is going to execute, right? Even though you said only one thread is going to execute at a time, but in this case maximum 2 thread is going to execute your application code. Minimum 1 thread is also possible when it is possible if your operating system, right, doesn't support multi-threading, right? So maximum 2 thread can execute our application code. What I'm using here, I'm using stopwatch. I'm starting the stopwatch and I'm stopping the stopwatch, and then I'm printing, right? One print statement is here which will print how many seconds this parallel invoke method took to complete the execution of this event task, right? This is a task parallelism, right? We are executing different methods. In this case, not a different method, but same method with different parameter, right? So what this do some task method is doing, it is just saying this task number is started by which thread, right? And we know that how you will get the current thread ID. So first of all, you need to get the current thread instance, which will executing your application code, and how you will get by calling the current thread property on the thread class, right? And then once you got the instance, right, then you can get the unique ID, right? The thread unique ID which is executing the application code, right? Then what I'm making the thread to slave for 2 seconds, and then I'm saying that the task is completed by this thread, right? And in this case, that thread is going to be sleep for 2 seconds. After 2 seconds, the thread will wake up and will complete the task, right? So that means at least how many seconds it is going to take? At least 2 seconds, right? Little more than 2 seconds it is going to take to complete the task. And I'm just calling that method 7 times, right? 7 times means it is going to take at least 14 seconds, a little more than 14 seconds to execute all the methods, right? To execute all the tasks, right? Let me run the application, right? And here I'm passing the first parameter. You can see maximum about 2 threads executing at the same time, right? So maximum of 2 threads executing the same time means it is taking little more than 8 seconds. Why? Now at a time, two tasks is completed. Two tasks means 2 seconds. Another 2 seconds, 4 seconds, another 2 seconds, 6 seconds. Then this is also going to take 2 seconds, right? 8 seconds. And 8 seconds, we are delaying the execution, but this is also going to take some time. And here I'm passing this parallel option as a first parameter. And if you go to the definition, one of the overloaded version taking the action array, right? The action array means you can pass multiple actions, right? And the first parameter is the parallel option, and that overloaded version I'm using here, right? So in this case, you can observe what is the total time duration? 8.0777, right? That is expected, right? Now what is my requirement? Now what is my requirement? You can see in this example, maximum 2 threads are there to execute our code, and that took a little more than 8 seconds. Now what is my requirement? My requirement is after 5 seconds, right? So in this example, you can see, okay, let me change this one. This is the wrong image. So in this case, I'm specifying 2 seconds. It should be 5 seconds. Right. So what is my requirement is after 5 seconds, I want to cancel the parallel execution. Within 5 seconds, the number of tasks completed, that is fine. But after 5 seconds, the execution should be uh, completed, right? Completed in the sense the execution should be cancelled, right? Then how you can do this? First of all, you need to create an instance of a cancellation token source. You know what is this, right? Create an instance of cancellation token source. While creating the instance, you can specify the time in milliseconds or by using the time span class static methods, right? From seconds, from minutes, from milliseconds, that is also possible, right? If you are not specifying the time duration while creating the instance, like in this example, you can also set the duration by using the cancel after method, right? So you can see cancel cancel after, and using the time span class static method, I'm specifying the duration that after 5 seconds, the token is going to be cancel the parallel execution, right? And then you can see this parallel option class having one property called cancellation token, and I'm setting that cancellation token property by using the token property of this cancellation token source instance, because this cancellation token source class having one property called token, that token property is going to return me a cancellation token source instance, right? And that is what I'm setting here, right? And once you create this parallel options, right, the other things is also possible if you want to set, right? If you want to set the maximum degree of parallelism, that is also that you can also set here, right? So now let us try to understand this thing. Okay, let us do this manually, right? So first of all, what you need to create, guys, tell me. First of all, I need to create an instance of which class? Guys, tell me. Which class?
Cancellation
Cancellation
token.
token.
Cancellation token source. Here, can I specify the time in milliseconds? Yes, this is possible. Even though you can also set this property by using cancellation after, right? Here also you can specify the top property using milliseconds or using this time span, right? Both are going to be valid. Once you set this, right, then what if you go to the parallel option class, there is a property called cancellation token, right? So what I am going to do, I'm setting this cancellation token property. Now, if you go to this class, there is a property called a token, right? Token property. So what I need to do, I just need to use CTS dot token, right? My cancellation token is set. Yes or no? Cancellation token is set, and then I'm also passing that cancellation token instance as a parameter. Clear?
Yes.
Yes. So this is what how you need to use this cancellation token. The same thing we have done here. I'm already provided these things in the documentation, right? But in this case, right, this null is not required. When you call the dispose method, it is going to do the things, right? So you can see if you go to the cancellation token source class, then you can see this is implementing the iDisposable. So once you use this cancellation token source, then you can uh, dispose the same thing, right? So how you can dispose, the best place to dispose is CTS dot which method you need to call dispose method, right? We have already discussed dispose pattern in our previous sessions, right? So if you are new to this, then I would recommend it to understand this dispose pattern where we are discussing the destructor concept, right? So that's it, right? Now what you need to do is you just need to run the application. Two threads started, four threads started, six threads started. Then you can see the operation was cancelled, right? Now let me give you another idea. Instead of five, I'm providing a three, right? Instead of five, I'm providing 3 seconds, right? So in this case, you can see how many threads are going to be successful, right? Only two times it started execution, then the operation was cancelled, right? So here you do not need to do anything extra, anything special. You are calling this invoke method, right? That invoke method will take care everything. That invoke method will check this parallel option class. That invoke method will check this cancellation token property, and accordingly he will cancel this execution, right? Whatever number of thread calls have been done, right? Those thread are going to be completed, and the rest of the things, right, which are not called, right, they are going to be cancelled. Is that clear, guys?
Yes, yes.
Okay. So in this case, we have seen how to cancel the execution of these parallel options, right? Using this invoke method, right? It is not this thing is not only applicable to invoke method, right? But also it is applicable to parallel.for and parallel.for each loop also, right? Let me show you the examples so that you will get better clarity, right? So I'm doing the same thing, right? Let me remove this additional line of code. Let me put this inside this one. Now you can simply ignore this, right? I don't know. I'm not in the for of writing multiple statement if that is applicable or achievable using a single statement. If this is applicable, achievable, then this is not required for me, right? I'm just passing this token to this parallel option class cancellation token property, right? So here I'm creating a range of integers starting from 0 to 20. And we have already discussed this is the starting integer number. And sequentially, it is going to generate this number of integers. So 0 to 19, what is going to be stored inside this collection, right? I'm using a for each loop, passing that integer collection. Each element I can access by using this I variable. And I'm also passing this parallel option instance here, right? And this for each loop will check this parallel option class, right? And then it will decide, or the task scheduler will decide how many threads are going to execute this code, right? And here, yes, it is available. Parallel maximum degree of parallelism is 2. So maximum 2 threads is going to execute this application code. And it also check this cancellation token source property, right? And using this cancellation token source property, it will check when the task is going to cancel, right? Here I have set 5. That means the task is going to be cancelled after 5 seconds, right? And then within the body, what I'm trying to do, I'm making this thread to sleep for 1 second. And then I'm just printing the value of I, which task is executed and by which thread, right? And if any exception occurred, right, definitely there will be one exception because 20 items are there. At a time, 2 items is going to be processed. That means in 5 seconds, 10 items is going to be processed. After 10 elements, right, the ones it will start 11, 12 elements, right? At that time, it is going to throw the task cancelled exception, a task got cancelled, right? That is what I'm printing here, right? Finally, what you need to do, you need to call this dispose method, right? So once you call this dispose method, this token source is going to be destroyed, right? So let me run this application and show you the output, right? So 2 tasks started. But guys, you can see, uh, don't think that the task is going to start from I value 0, 1 like this sequentially, because it is not sequential execution, right? This is parallel execution. Randomly, it will pick the elements, right? You can say 10, 0, 11, 1, 2, 12, 13, 3, 14, 4, right? And after 2, 4, 6, 8, 10 tasks, the operation was cancelled, right? So any question from anyone? Guys?
No.
Right. So the same thing is also applicable to the for loop, right? Parallel version of the for loop. Let me show you the example, right? So once you understand the basic concept, right? Once you understand this parallel option class, and once you understand this parallel for loop, right? And if you understand what we have discussed in our asynchronous programming using this cancellation token, then this is nothing but the same, right? So the way you are canceling the operation of asynchronous programming, this is the same way, but the approach is a little bit different. You can create an instance, set the, so in this case, I'm not interested with this one. I'm going to use the other overloaded version, right? So if you go to the cancellation after method, right, you can see there are 2 methods. One is time span delay and another one integer milliseconds delay, right? So here I'm using integer milliseconds delay. So integer means I can pass an integer number. So this operation is going to cancel after 5 seconds. I'm doing the same thing, creating an instance of a parallel option class, passing this, setting this value to 2 and passing the cancellation token to this, setting the cancellation token to this cancellation token properties. right? Then I'm using for loop 121. This is inclusive, and this is from inclusive to exclusive. Can anybody tell me what is the difference between from inclusive and to exclusive?
Means it will include 1, but it will not include 21. So it will be till
Exactly.
20.
Exactly. It will start from 1, it will include this number, but it will exclude this number. So the loop is going to start, or loop will execute from the integer value 1 till 20, right? And then I'm using this parallel, I'm passing this parallel in option class, and I can access each of this number by using this I variable, right? And then I'm just executing the loop. But here also I'm delaying the execution for 1 second, and then I'm just printing the I value, and I'm just printing which thread is execute this piece of code, right? Again, the same thing, catch block is there, finally block is there. Don't CTS is null, this is not required. Rather, what you can do here is, if, right, instead of writing this, if CTS is not equals to null, right, then you need to dispose it. This is the best option, right? If it is not null, then only dispose. If it is null, then don't dispose it, right? So if it is not null, then you need to dispose. If it is null, that means that is already disposed. In that case, you do not need to call the dispose method. This is the better approach, right? So in this case, let me run the application, and you will again see the same thing, right? Parallel execution will start at a time. Two threads is going to execute the application code. You can see 415151 414, right? And then the operation was cancelled, right? So this is how you can cancel the execution of a parallel for loop. You can cancel the execution of a parallel for each loop. You can cancel the execution of a parallel.invoke method. So you can cancel the task, right? So we have two types of parallelism. One is data parallelism, which you can achieve by using for loop parallel.for method or parallel.foreach method. Both you can cancel, right, using this parallel option class, this property. Even we are having some task parallelism, which we can achieve by using parallel.invoke method. That is also cancelable, and by using the same parallel option class cancellation property. Any question from anyone?
No question, sir.
Nope.
Okay, fine. So the next thing what we are going to discuss, atomic method. We'll try to understand thread safety. We'll try to understand rest condition. So we already discussed what is thread safety and how we achieve thread safety. Can anybody tell me what is thread safety? Right. And this thread safety concept will come into picture in sequential programming or in multithreading?
Only in parallel programming.
Not only parallel programming, this concept is also available in multithreading. I'm not talking about parallel programming. I'm asking the question. This thread safety concept will come into picture in sequential programming or in multithreading?
Definitely multi-threading. Then two threads are
Multithreading,
trying to execute
right?
one resource.
Right. So basically, whenever two threads are trying to access the same resource, then sometimes we may get some inconsistency behavior, right? Inconsistency behavior means if two threads trying to update the same data, then the output or the behavior is going to be a different one. What is we are expecting, we might not get that thing, right? And to achieve that, that means what? That means the thread is not safe, right? The resource what we are accessing by using multiple thread, that resource is not thread safety, right? Then what we need to do? We need to provide thread safety to our shared resource. And how you can provide thread safety? We have discussed many things. We have discussed by using locking mechanism. We have discussed by using monitor class, right? We have discussed semaphore slim, right? Many things we have discussed how to achieve thread safety, right? The same problem we will also face in this parallel programming also, right? Let us try to understand what do we mean by atomic method, what do we mean by thread safety, and what do we mean by rest condition, right? So as of now, right, so far whatever we discussed in parallel programming, Means we have discussed three methods. What are one is for method. This is not basically it's a method, but its behavior is similar to the for loop. But the difference is that for loop will execute the loop body sequentially. In this case, it is going to be execute the for loop body, right, by using multiple threads. This for each loop, it is equivalent or not equivalent. It is similar to standard for each loop, but here multiple threads is going to execute the code. And this is also this is invoke method. Means if you want to invoke multiple methods parallelly, then in that case you need to use this thing. So the point that you need to understand is, as of now, what we have discussed, right, all are independent, right? All are independent means, right, so in this case, if you see, this code is independent, right? Independent, and they are not accessing in shared resource. So for example, right, for example, if I create an X variable 10, right, let assume I created an X variable 0, and here what I'm trying to do, I'm just increasing this I variable by 1, right? That means what? Now this for loop, or you can say for each loop or anything, for or for each loop, right? Now they are accessing a shared variable. In this case, this X is shared or not? Right? This shared variable, what you are declaring, now you are accessing this shared variable. That means what? Now multiple threads trying to access this shared variable in a parallel environment. Yes or no?
Yes.
Right? That
Yes.
means if this is nothing but, in this case, this variable, right, what you are accessing by using different threads is not a thread set. This is going to give you inconsistent behavior, right? So this is not independent now, right now. As of now, what we have discussed, they are all independent, right? But in this case, the behavior is different. So in this case, this for loop, right, what accessing this X variable might be updated by the previous iteration, or it is also going to be updated by the next operation. That means the dependency is there. They are not now independent. They are dependent with each other, right? And when they are dependent with each other, right, then we may have some issue, right? So what, in the sense that in this case, we may have some issue. What kind of a issue? Thread set issue, right? So before understanding thread set, let us first understand what is atomic method. An important concept to consider is the concept of atomic method. What is atomic method, or what this atomic method can do is, atomic method can be used comfortably in a multi-threaded environment because they guarantee determination. That is, we will always obtain the same result no matter how many threads try to execute the method simultaneously, right? So what it means in this case, right, in this case, I'm using this shared variable, and this shared variable is going to be accessed by multiple threads, right? And in this case, the result is not going to be atomic. Why? Now, each time you run the application, right, you will get a different result for this X variable. And if you are getting a different result for this X variable, each time you run the application, means your application, right, that is not atomic. This method is not atomic, right? So what you need to do, you need to provide some mechanism, right, which will ensure that irrespective of number of threads trying to execute the method, right, always it is going to give you the same result, right? And if it is always going to give you the same result, then that method is nothing but atomic method, right? And this .NET framework provide one class, right? And that class having some atomic method, and we are going to use those atomic method to make sure that our shared variable, right, which is going to be executed or accessed by multiple thread, is going to give you the same result. This is nothing but atomic. Atomic means the behavior is consistent, right? Behavior is consistent means what? No matter how many times or how many threads going to execute your application code, right, concurrently, simultaneously, parallelly, the output is not going to be changed. The result is going to be same. If the result is the same, means this is nothing but atomic. Is that clear, guys?
Yes.
And how we can achieve this, right? How we can achieve atomic, how we can implement, or how we can achieve or what is the characteristic? Two things you need to remember. If one thread is executing an atomic method, right? If one thread is executing some code, some block of code, some statement, right? Some method, right? Then another thread cannot see an intermediate state. Another thread cannot see an intermediate state, right? If the operation is not started or operation has been completed successfully, then he can see. But once the operation is started, right, then he cannot see the intermediate state, right? What it or in other sense, what we can say, we can say operation will be completed successfully or will fall completely, right? So this is nothing but similar to if you anybody having any experience in SQL transactions,
Yes.
right? So what is SQL transaction? Transaction will make sure that either all the operations are going to be completed successfully or none of them. None of them means what? Now, if one of the transaction failed, then the whole transaction is going to be failed. Yes or no?
Yeah, right.
Right? And in that case, once one transaction access some data, right? Other transaction cannot see that intermediate data, right? What other transaction will see? What is the data before starting the transaction? And if the transaction completed successfully, then what is the data? That is what the other transaction is going to be seen, right? So in this case also the same thing is there, right? Once one transaction is started, right? Once the atomic method execution is started by one thread, then another thread cannot see the intermediate state. Cannot see the intermediate state means what? Now suppose one thread start, right? Suppose one thread one start, thread one read the value as 0, right? Thread one update the value as 1. Then in the same time, if thread 2 start, right? Thread 2 start, then he cannot see the intermediate value. He cannot see this value 1. This is nothing but intermediate value. He cannot see this value 1. And once he write this value, right? 1, right? Once the execution is completed, right? Then the execution completed done, then only he can see the or he can read the data, read 1. That means the intermediate state of a shared variable, right, which is executed by a thread, cannot be viewable by another thread. Practically, by taking some example, we'll try to understand this thing, right? So basically, what you need to do is you need to provide thread safety. And we have already discussed how to achieve atomicity. We have already discussed, right? We can use log, we can use monitor, right? Even though if you are having a collection, right? If you want to create a collection, right? If you want to achieve thread safety, then you can consider of using concurrent collections, right? We have already discussed what are concurrent collection, right? So concurrent bag, concurrent queue, concurrent stack, blocking collection, right? So these are nothing but concurrent collection classes, which is going to provide you thread safety, right? If you are creating a variable of concurrent bag, right? If multiple thread trying to access or update the data, then no issue, right? That is going to be internally implemented in such way that you will get correct result, right? Irrespective of number of threads trying to access the value, right? So basically, we have already know this log class, right? And we have already discussed this concurrent collection classes, right? By using this log and concurrent collection classes, right, we can achieve atomicity, or we can say we are going to achieve thread safety, right? Or we can say we are going to going to get the expected result always, right? If you are not using the proper locking mechanism, or if you are not using this concurrent collection classes, right? If you are not providing a thread safety to your shared resource, then you will end up with unexpected result, corrupted data, or incorrect values. Clear? Right?
Yes.
Then this is atomicity. Atomicity means the method is
Yes.
always going to give you the same result, right? No matter how many threads they are trying to execute the code, it is going to give you the same result, right? How we will achieve that atomicity, we will see practically. Log is already there, but apart from log, something else is there. That is what we are going to discuss. Another option is the term that we need to understand is a thread shift, right? An important concept in parallel programming is thread shift. When we say that a method is thread shift, we are saying that we can execute this method simultaneously from multiple threads without causing any kind of error, right? So thread shift means what? If multiple threads trying to execute the application code, and if we are getting the same output or same behavior, means our application code or our resource is thread shift, right? If we are not achieving, or if we are getting some unexpected output, unexpected behavior, right, then we can say the code is not thread shift. Then we need to we need to consider about making the code thread shift, right? Practically we will see this thing. What is race condition, right? Race condition, this is the new term. That is what we need to understand. There is a race between multiple thread to update, to access the data, right? There is a race between multiple thread. That is why it is saying a race condition. How will see practice? Race condition occurs in C# when we have a shared variable, right, which is shared by several threads, and these several threads trying to modify the variable simultaneously. That means we have a shared variable and multiple threads try to update the same variable, right? The problem with this is that depending on the order of a sequence of operation, right, the variable is going to give you different result, right? Multiple thread trying to access the shared variable, but at what order they are accessing the shared variable, right? Depending the order of the operation, we might get a different result, right? For example, right, why we are getting a different result? Because see, whenever we are doing one operation on a variable, right, either if you want to increase the value by 1 or if you want to decrease the shared variable by 1, but don't think that only that operation is going to be performed. In fact, behind the scene, three things are happening. What are the three things? You might be read the value. Once you read the value, then you can increase the value by 1. Once you increase the value, then you are going to write the value to the appropriate variable, right? So basically, three things is happening behind the scene, or you can say we can do three things, right? And the fact that three operations are performing, two threads can execute them in such a way that if we increase the value of the variable twice, only one increase will take effect, right? Let us understand this with one example, right? Suppose, so you can see I'm having three columns, column 1, column 2, and this is my column 3. Forget about this column. So let's assume we are having three columns. In column 1, I'm having thread 1. In column 2, I'm having thread 2. And in the third column or in the last column, I'm having the shared variable, right? Initially, I have initialized this shared variable with the value 0. Now, what this thread 1 trying to do, it is accessing the variable value, doing some internal operation, then it is incrementing that variable value, and once it increment, then it writes that variable value, right? So in this case, you can see the shared variable value is 1. After this operation is done, again thread to read the value, it will read the shared variable value as 1. Then it increment the operation by 1, right? Increment means, see, whenever I'm doing the increment operation, the shared variable value is not updated, right? When I update or when I write the value, then only that value is going to be updated, right? So in this case, thread 1 read the value. Thread 1 in memory increment this value, right? The value is not actually updated in the shared variable. Internally, it increment the value, right? So once so internally it increment the value means, you can say, suppose I'm doing this operation, integer y equals to x, right? So in this case, I'm just reading the x value from here, right? Then I'm incrementing this variable y equals to y plus 1. Right? So in this case, once I read the variable, so this integer y equals to x means this is nothing but your this statement. You will read the variable value. In this case, and after then you just increment the value. So once you increment this value, right? In this case, this y variable is increment or x variable is increment.
Why?
Why? So in that case, that I variable is incremented, not the x variable, right? Now, after doing something, so what I'm trying to do, I'm making x equals to y. So in this case, X variable is going to be increment or Y variable. So in this case, what will become X?
X will have the value same as Y.
Right? So that means whatever you have with Y, in this case 1, that will be written on this variable. Yes or no?
Yes.
So now in this case, again the execution started. Now it is reading the X variable. Now X variable is 1. Yes or no? That is what he read. Then increment the in memory data and then write the updated data to 2. And right now the Y value becomes 2. This is fine. This is expected. Why? Because the execution is sequentially. First thread 1 execute this code. Once the thread 1 execution completed, thread 2 started executing this code. Right? But what will happen if both the threads parallelly trying to update the value of the variable? Then in that sense we will face the problem. In that sense, right, we might get the shared variable value as 0, shared variable value as 1, or shared variable value as 2, depending on the sequence of the operation. For example, right, right. So let's try to understand these things, right? So in this case, what will happen? The same example, both threads start executing the operation parallel. That means thread 1 read the value 0, thread 2 also read the value 0, right? So in this case, for thread 1, right, thread 2 trying to do this operation, thread 1 also trying to do this operation. That in that case, both the thread will read the shared variable value as what? 0. Yes or no? Guys,
Yes.
are you getting my point on it? If both the thread trying to read this variable value, then both will read the value as a 0 or not?
Yes.
Right? And then both the variable is going to do this operation, means both the variable for both the thread, y value become 1, right? And then they are trying to update the same y value, right? So that means what? Now both of the thread increment the in value in memory, right? They are so this increment statement doesn't mean they are incrementing this x variable. This increment statement means they are reading the x value and in memory they are incrementing that value, right? And then what they are trying to do, they are writing the value back into this variable, right? So for both the thread, right, for both the thread, what will be the y value?
1.
1. And then when they are updating that shared variable, right, for both the thread, right, they are going to update the same value to this x variable or not,
Yes.
right? That means what? In this case, you can see the shared variable value is going to be 1. Even though we have incremented the operation, right, twice, right? But to one increment is take effect. Yes or no?
Yes.
Right? This is the problem, right? Thread 1 read this value, thread 2 1 and thread 2 increment the value in memory, and then thread 1 and thread 2 try to update the value in memory, right? This is nothing but your race condition, right? Race condition means there is a race between multiple thread to update the shared variable value. And sometimes we may get the data as expected, and sometimes we may get some unexpected data. How we can handle this race condition? Right? So basically there are two mechanisms that what I'm going to show you. One is by using interlock. What is interlock? That is what I'm going to show you. And the second one is lock, right? Both the, you know already what is lock. Even you know, I'm going to give you example, and I'm also going to give you example using interlock, right? And then I will show you what is the difference between interlocked and lock, and when to use interlocked and when to use lock, right? So first of all, you understand what is race condition,
Yes.
guys? So and now once you understand, then we need to understand how to handle this, right? And as we mentioned, we are having two options. One is locked and another one is interlocked, right? Both the options, both the approaches, I'm going to show you by taking one example, and then we will see when to use what, right? So race condition occur when we have a variable shared by several threads, and these threads wants to modify the variable simultaneously, right? That is what we have seen. We are having a shared variable and multiple threads trying to update the same shared variable simultaneously, right? The problem with is that depending on the order of sequence of operation is done, right? So you can see first read, then update, then write, right? We may get a different result, right? As the result is going to be different, so this is nothing but your race condition. And we have discussed we can overcome this problem by using interlock and the log. Let us first trying to understand the log variable. The interlocked class. The interlocked class, right, allows us to perform certain operations, right, perform certain operation in an atomic way, which makes this operation safe to do from different threads on the same variable, right? So what exactly this interlocked class saying? That this class provides certain methods, right? This class having some methods. Using those methods, we can perform the operation in an atomic way, right? Suppose you want to increase the variable value by 1, right? You can do this by using plus equals to write operator. But that plus equal what you are using, that is not thread safe, right? And to perfectly increment the variable value by 1, this interlocked class providing one method, right? And using that method, you can increment the variable value by 1, and that is also possible that multiple thread can increment the variable value by 1, but at the end we are going to get the same result, right? So let us first see one example, right? One example without using the interlocked class, then I will show you the interlocked class, right? So let me run this application, right? So you can see this is my shared variable. I'm using a parallel for loop, right? And as this parallel for loop is execute for this number of time, so my expected value is this, because this number of time this variable will be increased, and each time it increase the variable value by 1, right? So this is my expected value, and what is I'm getting, that what I'm printing here, right? Let us run this application few times. See, what is my expected output? This one. What I'm getting? I'm getting a different value, right? Now run another time, right? This time you are getting the actual result and expected result as it is. Let me run another time. You are getting a different result. So what it means? It means this is not thread set. There is a rest condition. There is a rest to update this variable value by multiple thread. As this variable, this shared variable value is modified by multiple thread, right? We are having a different value, right? Each time we run the application, we will get a different value. So in that sense, this right increment value or this shared resource is not a thread set. This shared resource is not thread safe, then what we need to do is we need to make the use of an interlocked class, and this interlocked class provides some mechanism, some method, and using those method, we can make sure this increment value, or you can say this shared variable, is going to be atomic. No matter how many times you are going to execute the application code, you will get the same output, right? Now, how? Let me comment these things, right? So this is interlocked. So this interlocked class is available in system.threading namespace, system.threading namespace. And if you go to the definition of this interlocked class, there are some methods. There is a method called integer increment and the long increment, right? If you want to increment one integer value, then you can use increment. And if you want to increment one long value, then you can use long increment. And here you can see I'm going to increase the integer value, right? So this is nothing but one integer value, right? So what I can make use of increment method, right? And you can see these are static method. Why static method? Because this class is static. As this class is static means by default, right, if, all the members should be static. There is no non-static member. So you can directly access by using the class name. And to this method, what I need to do is I just need to pass this value, right? And this increment operation, but if you go to the definition, then you will see that the parameter type should be preceded with the ref keyword, right? Ref keyword means what? Now this value is going to be updated by this increment variable, right? So now if you run this application, this increment method, so this is providing an atomic way of increment a specified variable and store the result as an atomic operation. Atomic operation means you will get the output as expected, right? No matter how many times you run the application, right? Now let me run the application for few times and let me see whether I'm getting the expected result and actual result are same or not. See, I'm getting the expected and actual result same, right? Now let me run another time, again same. Let me run another time, again it is going to give me the same output. Clear?
Yes.
Right? So this is nothing but one. So what is interlocked? Now this is a class provided by .NET Framework, and this class having some atomic method, right? Which you can do to perform some atomic operation, increment, decrement, add, exchange. Many methods are there which you can use to do some atomic operations, right? So instead of addition subtraction, you can use add, increment, and decrement, right? Suppose you are going to perform some add operation, some subtraction operation, right? Plus, plus, minus, minus, right? Then instead of doing that, you can use this increment, decrement, right? Operations, right? Let us try to understand a few more examples, right? So like increment, you can also the like increment, right? You can also do the decrement operation, right? So there is a method called decrement also. So that is what I'm not going to show you. You can try yourself, right? Another method is the add method. Let me show you that also, right? So in this case, what I'm trying to do, see, in this case, I'm creating two variables, some value without interlocked, some value with interlocked, right? So for some value which interlocked, right, I'm passing the number, that is what I want to add, and this number is going to add with this variable, and the result will be stored inside this variable, and the same operation, right? What is I'm doing without using interlocked method, the same operation is going to do by this add method. What this add method will do, so the add method will add this number, right? Whatever 0, 1, 2, 3, like this number with this variable, right? And that result will be stored inside this variable. So this is the statement what I have written without using interlock. The same thing is going to be done by this method. So whatever the number, right, this variable number, it is going to hold 0, 1, 2, 3, like this, is going to add this variable, and after adding, right, whatever the result, that result will be stored inside this variable, right? And in this case, this statement is not thread safe, but this statement, right, this add method is thread safe. So you will see that each time you run the application, right, without interlock, it's going to give you a different result, but this value sum with interlock, it is always going to give you the same result, right? So let me run the application. See, so some value with interlock, this is the result, this is the actual result, and in this case we are getting a different result, right? Let me run few more times. See, now we are getting both the result are same, right? Now let me run another time, right? Now you are seeing we are getting a different result for without interlocked, and for interlocked the result is going to be same. Clear?
Yes.
Right? So
So
basically you cannot do all the things, right? Whatever methods they are provided as part of this interlocked class, those operations you can only do using this interlocked class. If something else is there, then right, then you cannot use this interlock. For that you need to use lock. That is also I'm going to discuss. Yeah, someone asking any question?
yeah, so basically like on line number 14, for an example, when we run this program, so like multiple thread try to enter in this parallel dot for loop, right? But
Exactly.
on line number 16, like multiple thread can have access that
Exactly.
line number 16, but because of on line number 18 we have written interlock, so particular add method is locked, so only one thread at a time can execute that method, right? And till
See,
the time
yeah,
the
yeah.
another method
Exactly.
another thread
Exactly.
will wait to release
Exactly.
that add method. Okay.
Exactly. Exactly. But I will show you what is the difference between this. See, this thing you can also achieve using the locking, right? What is the difference between lock and interlock, which is taking more time, which is taking less time? Everything I'm going to discuss. But what I'm trying to tell you is, see, you cannot do everything using this interlocked class. Interlocked method are atomic, but whatever, right, increment, decrement, add, right, compare, right, these things you can only do. Apart from this, if something else is there, then you cannot do that using, right? That add method means it is going to perform the addition operation only. Increment method means it is going to do the increment operation only. Increment means plus plus. Decrement means it is only going to perform the decrement operation. Apart from that, if you are having a complex operation, that you cannot achieve using this interlocked class, right? Clear?
So wonder. So what is the number variable? How it takes the number there?
Did you attend our last session?
Yes, sir. Like after 10 minutes.
What is the this item variable? I'm asking you the question.
Each value of this list.
Each value of this list is going to store inside this item variable. Now
Yes.
you understand what is the use of number variable. So in this case, your loop is going to run for the value 0 to this number of time minus 1, right? But where you will store that value you are going to store inside this number variable. And within the body, you can access that value by using this number variable. Now you clear?
Yes.
Clear or not? See, if I'm not using this number, then how I can access this value? For accessing this value, I'm using this number. And you know what is this lambda expression? Before lambda expression, you have to specify the input parameter. And using this input parameter, you can access the value within the lambda expression, right? This input parameter is nothing but the input values, right? And this number is going to store this value 0 till this -1, right? Clear? Or still anybody having any doubt what is this number variable? Guys?
No doubt, sir.
Yeah, let's
No
go.
doubt there. No doubt there.
Okay, fine. So now we need to understand the one thing. What is the difference between interlock and lock from performance point of view, right? So basically, what I'm going to show you, I'm going to show you the same example using interlock. I'm going to show you the same example using the lock, and we'll try to understand which approach taking for what, how much of time, right? So basically, you can see this is a variable which we want to increment, right? So instead of saying this increment value, so let me give this name as increment value. right? So this is nothing but my increment value. I'm printing the increment value here, right? And I'm resetting this value to 0, and I'm using that also here, right? So instead of test, so this is nothing but number of iteration, number of iteration. So I generally prefer the full naming convention, right? Which should make any sense, right? So basically, you can see I'm creating one log object. You know what to create. So instead, if you are creating log object, then please make this as a read only, right? So that no one can modify this object, right? Increment value, number of operation, log object. Because if you want to implement a locking mechanism to provide threads to some code, right? And in that case, you need to create one log object, right? Then what I'm creating the stopwatch. I'm starting the stopwatch, and I'm executing this for loop to increment this variable value, and the for loop is going to execute for this number of times. So I will start with 0, I will less than this number of operations, and here I'm using the lock mechanism. So to this lock construct, I'm passing this lock object, and as part of this body, right, I'm incrementing the value, right? So this will ensure that this code, right, whatever I have written inside this lock object, right, is going to be accessed by a single thread, right? Then I'm using the stopwatch. I think we have done something else. So instead of that, we have to use parallel version, right? System.threading dot, right? Parallel dot for, this is going to start, this is going to number of iterations, and I'm going to store that number which is not required, and I'm just going to write the loop body within this method. Clear? That because we are using parallel programming. Now again, this is version 2. Right? So basically what I'm doing here, I'm looping through this number of times, and I'm just incrementing this variable value by 1, right? Using the locking mechanism. And then I'm stopping the stopwatch. I'm printing the result value, and I just print how much milliseconds this lock object took to complete the operation, right? Then what I'm trying to do, I'm resetting this value, increment value to again 0, and I'm resetting the stopwatch, right? How you can reset by calling the reset method, right? And then I'm implementing right. So in this case, this is not right. So in this case, I'm not implementing the locking by using lock, rather I'm using the interlocked class, right? And both are going to do the same thing. And now I'm going to print the value, right? Whether I'm getting the value and the time duration, right? Let me run this application. Result is the same, yes or no, guys?
Yes.
Yeah.
But can you check the log, how much milliseconds it took to complete the execution? 850. And how much time interlocked took?
252 milliseconds.
252
So
milliseconds.
which is giving you better result?
Interlock.
Interlocked, right?
Mm.
So interlocked gives you better result. So if situations like this, right, then you should go with interlocked, right? Yes or no?
Yes.
Right. Let me update this example, because the previous example parallel, what I'm putting in the document, right? That is not parallel. So we need to use this parallel version of the example because sequential execution doesn't make sense. Right. Now, when to use lock over interlock. So in this example, you can see definitely interlocked is going to give you the better performance, right? But situations is also there, right, where you need to go with the lock. Okay, let me give you the idea, right? So in this case, you can see this is my increment value and this is my sum value, right? I'm using this parallel for loop, right? I'm incrementing the variable value by 1 and I'm adding, right, this variable value to this. So here you can also some other statement, right? Some other statement also, right? Statement, right? Now try to run the application few times. Right, so try to run the application few times. In this case, what you will see, the increment value is always going to be this one, but the sum value, right, you might get a different result when you run multiple times. So you can see now I'm getting a different value for sum value, right, but the increment value is same. For sum value I'm getting a different value each time you run the application. Why? So now, are you getting thread safety? Thread safety?
No.
But if you look at the code, I'm using the increment method. I'm using the add method. This method is thread safe. This method is thread safe. But still, then why I'm not getting the expected output? Can anybody tell me?
Because on line number 18, increment value is like accessed by multiple thread.
Exactly, exactly. So in this case, now this thread, right, the code is going to be executed by multiple thread, right? So once one thread increment this value, right, and once that thread coming to this statement, right, at that time, right, it might be possible that multiple thread might be execute this statement. Yes or no? Right, while the thread transferring from line number or moving from line number 16 to 18, right, within that time period, once this thread execution is completed, it will move this statement to this statement. Na? For moving the statement from line number 16 to 18, it will take some time, right? Within that time period, it might be possible that multiple thread might get a chance to execute this statement. Yes or no? So as they
Yes.
have incremented, right? So when this statement is executed, right, it will get a different increment value, right? As it get a different increment value, right? So this result is going to be unexpected, right? So the point that you need to remember is independently this method is thread safe or atomic. Independently this method is atomic, but when you combine, they are not thread safe. Understand my point? So now I'm combining these two operations, right? Whatever I'm incrementing, I'm using that inside this add method. That means it's going to be a combined operation. Independently, if you write the statement, no issue. This is going to be atomic, thread safe. Independently, this method is going to be thread safe. But when you combine these two statements, right, they are not thread safe because while they are moving from one statement to another statement, at that time it might be possible that multiple threads trying to execute multiple thread execute this statement. So if multiple thread execute, for example, initially the loop one started. For loop one, this is the increment value, right? It will become 1. For that thread, it should the value of the sum value should be 1. But while it is moving to this statement, another two thread execute this statement, right? For that thread, right, what increment value become 3. So for thread 1, it is going to be 3, which should not be the case, right? So in that sense, the output of this add operation is going to be inconsistent, right? So situations like this, you should not use interlock. So what you need to use, right, some static read only object, lock object, right? New object, right? So you should use this lock object. So using this lock object, lock, right? You need to pass this lock object, right? And here you can write these two statements. Let me copy these things from here. You should write these two statements here, right? So you should comment these things, right? Now what will happen? This log object will provide thread safety to both of the statement, right? Both of the statement are going to be executed by a same thread, and once both the statement are executed, then only the next thread will execute and enter into this log section or critical section and will execute the code. Now if you run the application, then you will get the expected output, right? No matter how many times you run the application, you will get this same output, right? One time, right? I'm executing is 2 times. You can see the output is going to be same, right? I'm going to execute one more time. The output is also going to be same, right? So the point that you need to remember is, right, why it is taking time, because of this, right? So thread, this operation is thread safe. This operation is also thread safe, but combining union is not thread safe. Why? Now, while once this operation is performed, right, when it moves to the next operation, in between this moving time, right, another multiple threads, right, might be execute this statement, which might be increase this increment value variable. And if this variable value is incremented, then you will get a different output, right? So individually increment and add methods are thread safe, but the union of these two methods are not thread safe. Clear, guys?
Sir, one
Okay.
doubt.
Yes.
The output that you are showing, the increment value is 10 lakh, whatever the value is, and the output value is same. So is it for whole run for all the iterations, or is it is for one particular run?
I don't understand what is the meaning for one particular run and whole iteration.
No, so like suppose you are running the start button, you
Yes.
get the output.
See, first of all, you just tell me where I'm printing this value.
Okay, outside the loop. So that is for
Outside,
whole run.
obviously, once this loop execution completed, then only I'm going to print the value. That means, and this loop incremented and decrement value, I'm updating as part of this loop body. That means this is for whole loop, right? Once the loop completed, then only I'm printing the value.
So in that case, we can write two interlock statement in a method and call it using parallel.in.
So two interlocked statement, why? If you are writing this two interlocked statement, right? Even though I'm also writing this two interlocked statement within this parallel part. So this union is not a thread safe. Independently, this method is thread safe. This add method is also thread safe. But while I'm performing the operation in union, right? This is nothing but two operations, right? Then this two combining these two is not a thread safe, right? Because one thread executing this statement, another thread executing this statement, this is the issue, right? But in this case, right, there is no chance that one thread executing this statement and another thread executing this statement. This is not the case, because in this case, both the statement we are putting inside this lock object means both the thread are going to be executed by a single thread only at any given point of time. In this case, as you can see, this thread is going to be executed by a thread one. It might be possible that this statement is going to be executed by thread two, right? As the two threads are one thread accessing this one, another thread accessing this one. Because of this, we are getting the inconsistent behavior.
So can't we use a combination of lock and interlock methods?
Combination of log and interlock means what?
Like these two interlock statements can we put in lock object?
So what if you are putting these two interlock statement inside the lock object? That is fine, but what is the use?
So these two will be
only one thread is entering inside this block. Then why I'm going to make use this interlock statement again? Because I know this statement is going to be executed at any given point of time by only one thread. Then why I'm putting that inside this interlock, inside this lock? Because see, if you are using locking or if you are using interlock, behind the scene they are also going to take some time. If you write this two statement, no issue, right? You will get the output as expected, right? But the problem is that it is going to take more time,
okay.
right? Because nothing is free in this world. You can say, oh, yesterday we have discussed, na? If you are using parallel, right, then also behind the scene it is going to take some time. If you are using an interlock, it is also going to take some time. But you just tell me, in this scenario, does interlock require?
No, it's not nice.
If it's not required, because we are providing the thread safety using this lock, na? That means only one thread execute this statement. Then why I'm going to again make sure that one thread is going to execute this statement? Because already that is handled by this lock object, right? Clear, guys? If someone asks you what is the difference between interlocked and locked, right? Using interlocked, independent method are thread safe. But if we want to union some of the method, right? The union is not a thread safe, right? And in that case, we may get some inconsistent behavior or inconsistent output. But this is not the case in the case of a lock object. So if we want to provide thread safe to multiple statements, right? Then in that case, we need to go with lock. And if for independent statement, only one statement which we want to provide thread safety, right? Then in that case, we can go with the interlock. Clear?
And so this interlock method we can use for all the parallel classes, no, like for each and or
See, this interlocked not only for parallel for each classes, right? So wherever you used lock, there you can use interlock, but the use is a limitation, right? If you want to provide thread safety to multiple statement, interlocked, using interlocked you cannot, right? What you can do using interlocked means whatever the method, right? They are providing those operations you can do only, like add, exchange, right? Increment, decrement, right? These things you can do only using interlock, right? So some complex calculation, right? There is no method provided by interlock where you can do the division operation or where you can do the multiplication operation, right? Interlocked basically some shared variable is there. You want to increment, decrement, add some values, right, to that variable. Those kind of things you can manage to using interlock.
so we can use it in like not only in parallel but also in like asynchronous and multi-threading.
Asynchronous, have we used this locking mechanism in asynchronous case? Not required. Why we are using asynchronous programming when we are interacting with the external system? Then in that case, locking is not required. Multi-threading, yes, locking is required. Parallel programming, yes, locking is required. But for asynchronous programming, we never used interlocked or locked mechanism. But because why? Because that is not required. Why we are using asynchronous programming to when we are communicating with the external system, right? That is nothing but your IO bound operation. In that case, this is not required. Why I'm going to use the lock while I'm calling the some external API? Does it make any sense? No. When we are going to use lock, when we are going to perform some heavy CPU bound operations, right? In this case, this is a heavy for loop, right? This for loop is going to take some time. For that purpose, I'm using parallel version. And as this is going to be executed by multiple thread, right? Then in that case, right? In that case, I need to provide thread safety. But in the case of asynchronous programming, right? Only one thread is going to execute that call. Only one thread is going to call that API. And why we are using asynchronous programming means once we call that API, we do not want to block the thread until we receive the response from the API. We want to release the thread. For that purpose, we are using asynchronous programming, right?
Okay.
Right? You need to be very clear, right? Where, when, and where we need to use this locking mechanism, right? When multi-threading concept come into picture, then in that case you need to use asynchronous program. What is sorry, you need to use this locking mechanism. What is asynchronous programming means? Properly utilizing the thread, right? One thread, properly utilizing the thread means what? Now, we do not want to block the thread. For that purpose, we are using asynchronous program. Right? Any question from anyone?
No.
Right? And one more concept related to this parallel programming is there. That is parallel LINQ, which I'm not going to discuss now. That I will discuss once we cover the LINQ concept, right? And from tomorrow we are going to start edu.net. As I mentioned, please be ready with your SQL Server database, right? So we are going to start edu.net, and in this week only we are trying to complete the edu.net concept, right, in detail, right? Everything what is related, what is connected architecture, what is disconnected architecture, right? How you can manage transactions, right? What is connection pooling, right? Data set, data reader, everything we are going to discuss as part of this course, right? So any question from anyone for today's session?
No. So like one question for edu.net. So like before we need to learn edu.net, do we need to clear some of the like topics? Because as you know, like I joined this batch in intermediate, so right now I'm like parallelly
Right. For edu.net, there's multi-threading is not mandatory.
okay, it's a multi-threading async await and
You
parallel
should,
program is
it's not required, but
not required.
you should have the OOPS concept, you should have the collection framework,
Okay, got it.
right? But try to complete this concept, this asynchronous programming, multi-threading, and parallel programming, because these are the advanced concept, right, which are needed, right, for developing good and robust application with by considering the performance in mind, right? So if you want to develop performance-based application, these concepts are very important, right? And those who have attended, right, I hope they should know the real use of this multi-threading, parallel programming, and asynchronous programming. Because we didn't just cover the basic things, right? What is thread object, how to create, and how to call. Each concept we are discussed with many interrelated concepts, right? So when to use, how to use, right? If you are using some parallel operation, then how you can cancel, right? If you are using some async operation, then how you can cancel, right? I'm not only covered the async and await keyword, right? Multiple things we are covering, right? It might be possible that some of the things you might not use, some of the things you might not be seeing in any of the existing project, right? But you should know these things,
Oh, sure.
right?
Of course.
So don't think that whatever we are explaining, everything you will find in existing project. No. Why? Because see, the person or the developer who develop the application, right, based on his experience, he will develop and he will write the code. If he know the concept, then he will use the concept, right? See, in this case, if he doesn't know what is interlocked, and if he want to increment the value of a variable, then he will go with the locking mechanism, because this is the one which most of the people know. But interlocked is one which most of the people are not aware about, that interlock. And if you simply need to provide one mechanism to increment the variable, shared variable value, instead of going with lock, you should try to use interlock, right? Because interlock will give you better performance comparing to your lock, right? So many things that you need to take into consideration while developing the application, right? Not only log, we are having monitor class, we are having semaphore sleep, mutex, right? Many classes we have discussed in multi-threading, right? So you should give some time, right? Once you give some time, then definitely you will learn and understand the concept, right? Even if anybody having any issue, right, then we can also take some doubt clearing sessions on weekend, right? But for that, you just need to inform me, uh, based on my availability, we will schedule the doubt clearing sessions. right? But you should know what are all these things. Right? These three things, that is multi-threading, asynchronous programming, and parallel programming, all are interrelated with each other. Clear? Okay. Thank you, guys.
Thank you,
you.
sir.
Have a good
Thank
day.